Okay, so I will paste the links to all three documentations. So this is Vodka, and then the standard library for Aiken, and the last one is like the general Aiken site. So yeah, you can keep all these three open, and then you can start taking a look. Along with that, it is a good idea to keep Undum your app open. This is basically the app that you have been working on. So I'll share the link for this as well. So I think these four would be enough for now. But if you are a little more excited and want to check stuff out, you can open the Preprod Explorer as well. This is where you can actually check the different transactions on Preprod network. Uh, I'll just, yeah, so all these four would be a pretty good. Yeah, this is a pretty good list to keep open for now. It is 3:05 p.m. So let's start off. So just to start with, I would prefer to keep this session a little bit more interactive. So just to start off with, can anyone tell me what a validator does? A Cardano validator, what does it do? What is its main purpose? You can be wrong, that's totally fine, but I want you guys to try at least. Anyone? What does a Cardano validator do? Any tries? Okay, so let me take that answer. So a Cardano validator either accepts or rejects a transaction. Okay, that's all a Cardano validator does. It either accepts or rejects a transaction. And what is a transaction? If you go to the standard library, Aiken standard library, you see this object. Just type in transaction, TRAN, and you see transaction. Click on that, and you see this. This is what a transaction is. So a Cardano validator either accepts this transaction or rejects this transaction based on the different fields. We'll fill in the different fields for different transactions. So it checks those fields and either accepts it or rejects it. Acceptance is yes, which is a true, Boolean true. Rejection is a Boolean false. As simple as that. Okay. So if you want to get good at writing validators, I think you need to get very, very, very familiar with this transaction object. Okay, so this transaction object has some primitive data types like list, pairs, etc. And then value, Lovelace, these are all primitive types. Okay, so you need to get familiar with that along with some higher level types, like input is a higher level type, output is a higher level type. Okay, now can anyone tell me one thing? Can anyone tell me what a list is? Like a basic list in programming, what is a list? Anyone?
Yeah, a list is like a function used to introduce a set of data, a set of related data or something like that. Yes.
Correct,
Yes, for
correct.
example.
Mhm.
Okay, yeah, yeah,
No, that is
yeah.
100% right. A
Okay.
list is a set of the same type of data. For example, if you see the inputs in this transaction, is this big enough? Is it clear enough? So if you see the inputs here, it says list and it says the type input. And how do I know it is a type? Because of the capital letter I. Anything that starts with a capital letter I is either a type or a constructor. Okay. So a list is a set of inputs. That's all it is. And all in a list, everything has to be of the type input. If it's of a different type, it's not a list. Is that clear? Okay. So that's what we have here. You guys need to get very, very familiar with this transaction object. Okay. So now I have another question. So in Cardano, are you guys familiar with addresses? There are two types of addresses in Cardano. Can you tell me what are the two types of addresses in Cardano? Anyone? I'm going to wait 15 seconds. Anyone? Two types of addresses in Cardano. What are the two types of addresses?
Sorry, okay. I don't know. Okay, is a validator address part of it?
Yes, that is one type. What is the other type?
Um, ah, a validator
You got it. You
address.
got it. You got it. Yeah.
Okay, yeah, yeah. Thanks.
And the other address is the address we all use. Like, for example, you look at this. This is another, it is a pub key address. Okay.
Payment address.
Payment, yeah, payment address or pub key address. Yes. So a pub key address is an address that is controlled with a public and private key pair. Public key is just the direct address you see here. That is the public key. Okay. And the private key is the secret key that I used for signing transactions. Okay. So this wallet or this address is created with my public private key pair. Okay. So all of the UTXOs. So in what does an address contain? An address contains UTXOs. Okay. A UTXO can be spent from an address if it's a pub key address. Then if I have the private key of that public key, then I can spend the UTXOs from this address. But if it is a validator address, how can you spend the UTXOs from that address? Anyone, can you give it a try? So in a personal address or a pub key address, if I have the private key, I can spend UTXOs. But in a validator address, how can I spend the UTXOs in that address? Any guesses? I'll give 10 seconds for this. Any guesses? How can you spend UTXOs from a validator address? Okay, let me take that. You can spend UTXOs from a validator address if the transaction satisfies the logic of that validator. Okay. Say, for example, let me randomly open this. Okay. So you see a validator here. Yeah, you see a validator here. It's called check script input validator. Okay. And this validator will eventually have an address, and we can send UTXOs to that address. If the transaction we are sending here, you can see a transaction. If this transaction right here satisfies this logic, then you can spend the UTXOs from that address. Is that clear? Makes sense? So today is the last class. So whatever questions you have, it is a great time to okay, someone has a hand raised. Yeah, you can go ahead. You can unmute yourself and ask the question. Yeah.
Yeah, so please, I don't mind if you come again, right? Come again, because I didn't get you what you
Correct.
said.
Correct.
Yeah,
Correct.
yeah,
Okay.
yeah.
So a validator address also has UTXOs just like our regular address. It will have UTXOs. Someone sends UTXOs to that address. If you want to spend that UTXO from a validator address, that means the transaction that is trying to unlock the UTXO, which is this, you see the spend. What is it trying to spend? It is trying to spend an input reference, which means a UTXO from a specific validator address. So this transaction has to satisfy the conditions put forward by this validator. Does that make sense? You're checking different
Yeah,
things
yeah,
in this
yeah, yeah.
validator. Yeah. So yeah, so that is how you unlock UTXOs from a validator. Now, a very, very, very basic questions. You have to understand this if you want to understand blockchain programming. What is a UTXO? Anyone? I'll give 10 seconds for this. What is a
Yes.
UTXO?
So UTXO is unspent transaction output. Yeah,
Unspent
so
transaction output. Correct.
an
Yes.
output, yes. So in a UTXO contains Okay, during every transaction, UTXOs are being spent, all right?
Correct.
So yeah. And Emmanuel made mention to us how it works. It's just like a person sending either to another person's account. There's an input and output. It's in a UTX, you have the input and the output. So unlike Ethereum, that's just like normal deduction. The inputs and the outputs changes at the end of the transaction. Yeah. So
Correct.
that's
Correct.
that's
So
really
yeah, inputs and outputs are always UTXOs. Remember that. You take in existing unspent UTXOs. UTXO is basically unspent, and then you spend them, and then you get new UTXOs, new unspent transaction outputs. Okay. If you want to take a look, let's open this. Say, for example, all of these are UTXOs. Some other UTXOs have been spent to create these UTXOs. Say, for example, I'll click on this, right? So what do you see here? You see inputs, right? You see inputs and then you see outputs. So some two inputs have been spent from these addresses and two outputs have been created which went to these addresses. That is what it is saying. So two unspent inputs have been spent to create two unspent outputs in this case. Okay. So this is just an example. Uh, what was I talking about? Oh, one other question. In UTXOs can have to contain value, but optionally they can contain information. Okay. UTXOs always have to contain value, but optionally can contain information. What does that mean? Can anyone tell me what that sentence means?
okay. Contains values symbolizes like the amount you're about to spend. Yeah, the values, that's the amount you're about to spend. So
Correct.
the information about it simply means like information pertaining to the owner's address. I don't know if I'm right about that. So
Yeah,
I'm not
let
getting
me explain what I'm saying. So
it.
if you look at all of these UTXOs, I'll come to you. Someone raised their hand. I'll come to you. I'll just finish this thought and then I'll come to you. So all of these UTXOs, if you notice, all of them have value in it. It has ADA value in it, right? And in some cases, it has other tokens. This is a random token, right? Some pilot one, some other random token. So all UTXOs should have a minimum of one ADA and it can have optionally other tokens as well. Okay, so this is value. A value is an object that combines ADA and some other tokens, and it's a combined object. So that is what a value is. Okay, does that make sense? If you want to clearly understand what value is, we can actually do this. Value. Okay, so I typed value with a capital V. That means it is a type. A multi-asset output value contains tokens indexed by policy ID and asset name. So a value is an object with multiple smaller objects inside of it. Okay. And each of the smaller objects contains policy ID, asset name, and number of tokens. Policy ID, asset name, and quantity. That is what makes up a value. Is that clear? Say if I'll just give you an example, I'll write this down so it'll be slightly more clear for you guys. Um, Say for example, I'm creating some value, right? Value in my, let value in my address, say for example. And I'm creating a value that will have, so I'm going to accept this. You see this? What does this value have? It has 10 million Lovelaces and some other asset with a mock policy ID of 0 and no name, or I can put a name called XXX, whatever. I can put whatever name of the quantity 1. You see that? That is how a value object is built. So, and I can keep adding assets. I can add another asset. I can add another asset which will look like this. So I can literally just copy this guy and change up the I'll say policy ID 2, and I'll say instead of XXX, I'll say 222. So this is the second asset. So this value object contains Lovelace and different assets, but it doesn't have to contain any of these. So say, for example, I can remove the Lovelace. Now this value object only contains assets. So what is the importance of this value object? When you are putting assets into a transaction, you have to convert it to a value object before you can put it into a transaction. Is that clear? Does that make sense? Now is a good time to ask questions. Also, someone raised their hand. I forgot to talk to them. You can unmute and come out right now and ask whatever you have in mind.
I don't have a question. I was going to answer your question about a transaction that has information. I was going to say that those are EUTXOs. So what will carry those information are datum.
No,
That is
no,
why
no.
it's an extended or spent
No,
transaction output.
It's not EUTXO. There are only UTXOs. I was only asking about UTXOs. I'm speaking about
Oh, okay.
UTXOs when I say information and value. Okay.
All right.
Yeah. So is it clear what value is? Are you guys clear about what value is? Is it making sense? Value is just a type that we convert assets into before putting them in a transaction. Okay. If this is clear, we'll move on to the next one. Okay. So now that we have value, how did I get here? I forgot. I forgot what I was talking about. Oh, yeah, yeah. So I was talking about value and information. So now in a UTXO, we are carrying the values. All this is the combination of both of these is the value. Okay. And information. So information is optional. It does not have to carry information, but it can carry information. So for that, let's try this. I'll go to one of my other wallets because I have UTXOs with datum there. So this information is called datum. So any information that a UTXO contains, that is called datum. Is that clear? Are you guys clear about what datum is? Let's see. So I can't directly see datum right here. Does this have datum?
Maybe if you should go to the pre-prod scan, maybe you'll see a random transaction you can point to data.
Yeah, but yeah, that's what I thought as well. But I was like, how do I look for? Should I just look for transactions and check for a random transaction? Inline datum. Okay, so this is datum basically. When you look at it, this is all information that exists in a UTXO. Okay, someone put all of this information. I'm not sure who, but this is how you'll see the information on a UTXO. How will this information be used? That we will decide based on our validators. Okay. So one other question after this. I showed you one kind of datum, which is inline datum. That means you can actually read that data or that you can read that information. There is one other kind of datum. Do you guys know what that other kind of datum is? Anyone? I'll give 5 seconds for this. Okay.
So
And
please, do you mind coming again with the question?
absolutely. So right now, what we looked at here is inline datum. Inline datum is information that you can directly read. So you can read all of this, right? Like bytes, 6, 9, 60, you can read the bytes here. Similarly, you can read the bytes here, you can read the bytes here. So all of these fields you can actually read. But there is one more type of datum. Do you know what that other type of datum is that can be put on a UTXO?
Sorry, is it binary codes? Is it binary?
It is not binary code, but it is very similar. It is called a hash. Does anyone know what a hash is? A hash is a very important concept in the blockchain. Does anyone know what a hash is? Any guesses? 5 seconds for this. 5 seconds. Any guesses on what a hash is? Okay. A hash is a one-way function. So any information can be hashed. For example, there are different hashing algorithms. So any information can be put into an algorithm and it'll create a hash. Okay. Hashing algorithm. I'm just looking for any hashing website where you can actually put in the information and you can directly hash it. String hash. So anyway, hashing is a function, like hashing algorithm is a function that takes in data and creates a hash. So the beauty of a hash is if you change even the smallest thing in the data, the hash changes. Okay. When you have data, you can create a hash, but when you have a hash, you cannot create the data. Does that make sense? So it's a one-way function. Okay. So the other type of datum I was talking about is a hash. You can put a hash here instead of all this data. What I can do is I can directly copy this data. I can directly copy all of this data. I can hash it and then put the hash here. So you won't see all of this. Say, for example, this hash is here, right? So since this is inline datum, I'm able to read it. So they put the whole datum and then I'm still able to see the hash. But if it is not inline datum, if it's just a data hash, all you'll see is this hash, nothing else. Okay. So why is that important? What is the point of having a hash? The point of having a hash is that you can keep the information secret. So if the hash is put here, this information becomes secret. But if someone else, some trusted third party or some trusted party has this information, they can use this hash. How can they use it? They can actually, if they already have this information, so they can hash this information and check if this hash and the hash they have is matching. So you can make sure that the information is the same information. Does that make sense? Is it slightly making sense? Like the point of hashing? The point of hashing is data integrity.
Yes,
It's making
Yeah.
sense.
yeah. It's making sense.
Yeah. Perfect. So the point of hashing is just data integrity. Okay. So now we understand what hashing is. What else do we need to know? Let's see. Just drew a little thing. So this is an address. Address has UTXOs. UTXOs have value and information. And value is either made up of ADA or tokens or one of those or all of those. Okay, all of that. Cool. So we spoke about all of these. Now let's see what else we need to look into. I think you have a basic understanding of. I thought it'll be done in 15 minutes, but it took like 30 minutes. That's fine. Now we can finally get into some code. Okay. So this is the oh, someone raised a hand. Yeah, go ahead.
Yeah, please. Do you mind taking us back to the diagram? Yeah, the
Sure.
diagram
Yeah.
you showed us. Yes.
Sure. I will take you back. So this is an address. This can be a pub key address. That means an individual is controlling the address, or it can be a validator address. This address will have UTXOs inside of it. Okay. And each UTXO will either be made up of value and information or just value. Okay. And each of this value will be made up of Ada or Lovelace and other tokens. Is that clear? All of this?
Yeah, it's clear. It's clear. I'm good now.
Okay, perfect. Let's get to the code here. So, this is a okay. This is just a random function. So, how do you guys want to read code? So, there are two ways of reading code. So, one is just going line by line, and the other one is understanding the high level of what this validator is doing, and then jump into the internals of how the validator works. How do you guys prefer it? Should I directly jump into the validator and all of that and see what this validator is doing, and then check out some important patterns in validators? Let's do that. So it'll be quicker and we can get like a high level overview. So first, even before we get into this validator, they have defined a public type called datum. Okay. And this datum has two fields: minimum script Lovelace, which is an integer, and minimum script token, which is again an integer. So when you are defining this as like, when you're defining a type, this keyword datum, go ahead. Okay, so this keyword datum becomes the name of the type, but also it becomes the constructor. What does that mean? That means you can construct this datum. For example, say let some datum is equal to, now in this case, it becomes a constructor. So you have to use the keyword datum here to make sure that this some datum is of the type datum. Okay. And then you can basically give these internal values, this minimum script value and minimum script value. If you take out this datum type, this some datum will not be the same as this type of datum. Okay. You're just creating another object here. Does that make sense? Are you clear about the datum as a type and datum as a constructor? Let me give you one more example. So I can actually write this as datum1, and I can put this, and I can copy both of these guys into this. Okay. I can do this, and then I can also define another constructor called datum2. Datum2 with a completely other field. Some field integer. So now if you want to create the first item, so these are both of the type datum. But if you want to create this datum1, you have to use the keyword datum1 as a constructor. But if you want to create this second datum, then you have to use the keyword. So now I'll have to use datum1 to create this constructor because it will have these two fields. But if I want to create some other datum, some datum2, now I can use datum2 as the constructor and some fields. But both are of the type datum. Is that clear? Is that making sense? The keyword datum is the type name, and the constructor name is datum1 and datum2. But when there is only one type, say for example, I remove this, if there is only one type, then the constructor name and the type name becomes the same thing. Here the constructor name and the type name is the same thing. Does it make sense, this one? And before that, how familiar are you guys with types? Do you know what a type is? Anyone, do you guys know what a type is? In general, it doesn't have to be Plutus or
Yeah,
I
so
can,
a,
yeah. Mhm.
a type symbolizes, okay, according to Python, type symbolizes the type of data, be it like integer or float or bool or boolean or yeah. So that's
Correct,
it.
correct. That's exactly it. A type basically gives you an idea about the shape of the data. Say, for example, in this type datum, we created this new type. It has two fields. One field has an integer. The other field also has an integer. And I can create a third field, some random field called bool. Okay. So this type is telling us what the shape of this data is. Does it make sense? It just gives you an idea about the shape of the data. It doesn't give you the exact data, but it only gives you the shape of the data. Cool. Okay, so this is a custom type for the datum we defined. Remember, datum can be of any shape, any data shape and any data type. Of course, like the data types that blockchains can accept. But this is custom defined. Datum is always custom defined. We can define the data. We can put any information on the blockchain. So we are defining it. So this data type is defined by whoever wrote this validator. They said this datum information will contain minimum script Lovelace called an integer and another minimum script token called as an integer. So now let's go to the building of a validator. So wherever you see a keyword validator, that means this is a validator you're going to build. Keyword validator and then the name of the validator. So this validator takes two key parameters. One is token policy ID, which is of the type policy ID. How do I know this is of the type policy ID? Because of the capital P. Okay. Do you guys want to see what a policy ID is? Just to make sure. Policy ID. Policy ID again is a hash. Okay. How do we get this policy ID? By hashing a script with the Blake 2B244 algorithm. Think of an algorithm as just a function. Okay. It takes the input of the script and gives out the hash. Okay. So that is what a policy ID is. So what is a script? I mean, that's a basic thing. So in this case, if you want the policy ID of this specific validator, you just take this validator, you hash this validator, and then you get the policy ID from this validator. But this validator, you don't particularly need the policy ID because it's a spending validator. You need policy ID for minting validator when you are creating a token, not when you are spending a UTXO. Okay, but anyway, they are just giving two parameters. They're giving two parameters in this validator. One is a policy ID called the token policy ID, and one is an asset name. Okay, token policy ID and asset name. That is how you recognize a token. Think of it as a name. Say, for example, my name is Harsha Gullapalli. Harsha is my name. Gullapalli is my family name. Okay. So similarly, for a token, asset name is the name of the asset and the policy ID is the family name because it is derived from the script and the script is the family. That is where you're getting this from. So always remember, asset name is the actual name of the asset, policy ID is the family name. Okay, so now the next line after the parameters is the spend. Spending here is the script purpose. What is the script even meant to do? When you see spend, you know that this script is basically describing the conditions required for the transaction to be able to spend a UTXO from a specific address. Is that clear? Until here, is that clear? I'll give 5 seconds just in case anyone has questions, or if you don't understand, ask right now. It's okay. I can explain as many times as you need. Okay.
Yeah, it's clear on my side.
Okay, perfect. So this is a validator that describes the condition of spending. And always remember, for any spend condition, these are the required internal parameters. So what is the difference between these parameters and these parameters here? So these parameters are given to a validator when it is being deployed. Okay. These are the high level parameters, but these parameters inside the script purpose are given to it when you are building the transaction. So that is the high level difference. So these high level parameters are given to a validator when it is being deployed, but these parameters inside a script purpose, so there are many script purposes, spend is one of them, are given to it when you are building a transaction. Is that clear until here? So let's quickly take a look at this. So there are many script purposes, like I said. So look at here. There is a mint script purpose, and these are the parameters it takes. So these are all standard. I think it's a good idea just to like save this page and remember that these are the different parameters that each of the script purposes take. So mint takes redeemer, policy ID, and transaction. Spend takes datum, which is of the type optional, by the way. And then it takes a redeemer and it takes a UTXO. What is this UTXO? It is the UTXO that is being spent, right? So it takes that UTXO and it takes the transaction. Similarly, withdraw, publish, vote, propose. But I think as long as you're familiar with these first three, most of our problems will be solved. These are more like governance, those kind of things. Okay, so where are we at? Okay. So now we have completed this part. Okay, you can always come back. You can always ask me questions if you don't understand this part. Now let's get to the first part of it. So can anyone tell me what this line is doing? Let transaction flower brackets input comma dot dot is equal to transaction. Do you know what this line is doing? Anyone?
Look, can you
5
hear me?
seconds. Yeah, go ahead. Go ahead.
Okay, basically we are trying to destructure different properties from the transaction
Exactly.
type.
Exactly. So this line is saying, remember, transaction should be of the type transaction. And when it is of the type transaction, I want the inputs field from this transaction object. That is what it is saying. Say, for example, and how do I know there is an inputs field in this transaction object? Because it is of the type transaction. And if you want different fields, you can always go here and you can check. I always have to keep looking at this because these are all the fields available. And in this case, the only field that we care about is this inputs field. The rest of the fields, we just put dot dot. That means we don't particularly care for the rest of the fields. Okay. So now we have that inputs field right here. So the next step, expect some datum is equal to datum underscore OPT. Can anyone explain this line to me? Any ideas what it is saying? So even before you can explain this line, can you tell me what this option does? You are basically wrapping information with this option thing, whatever this option is. Do you know what that option does?
Okay.
Anyone?
I feel like just as the name implies, option, what it does is that particular datum is actually optional. So it's not necessary for probably the transaction to go.
Exactly. No, you are 100% correct. Whenever you are wrapping something with this option, that means this datum can either exist or not exist. So that's what it is saying. If it exists, you'll get a result of some, you'll get something. But if it doesn't exist, you'll get a result of none. Okay. So in blockchain, option is extremely important because remember, in a blockchain, the more computation that happens, the more cost it is. Say, for example, there are 1,000 lines of code in this validator. That specific validator, just to like do all of the computation, it'll cost a lot of money. So we want the code to be concise, small, and it should fail as quickly as possible. Okay. So for example, what this is saying is, it is saying this line specifically, expect some datum when it comes to the datum optional. Okay. If the result of this is none, the validator fails right here. It doesn't go through all of this and spend more of our money. It fails immediately. Okay. This is a two-way. This line does two things. One is destructure datum optional, and also checks if datum optional is of the type sum. Okay. So if it is of the type sum, then you can unwrap it from this option and call whatever is the result as datum right here. Make sense? Is that making sense? Am I, because I feel like I'm not explaining very well. Let me know if it is making sense and I can try one more
It's
time.
making sense.
Okay, perfect.
Sorry, please come again. Come again.
Yes. Okay. So when you are giving in the spend, when you're building the transaction, we have given this datum, which is of the type optional datum, right? But we want to make sure this optional datum is unwrapped from the option. Okay. So this datum right here is wrapped inside option. How do you unwrap it? The way you can unwrap it is by using the keyword expect and then keyword sum. So the option wrapping can give two results. If there is some data inside the option, it gives some data, right? Some data. So I'm just calling this datum, but you can just say something. Something is here. Expect sum means this option is giving out a sum. But if it gives out a none, the line fails right here. Okay. Does it make sense?
It makes
Let
sense.
me actually try and see if I can find option here. Option. If it's not here, I'll look here. Option. There it is. So option is defined like this. It is a type that takes in any kind of data and gives out either sum or none. Right? We saw how we define types previously in datum. You saw how types are defined right here. And when we remember, when we define two types, datum 1 and datum 2, that means the type datum can either be type 1 or type 2. Similarly, here it is saying option can either be sum or it can be none. And in our case, in our code, what we are saying is we are expecting sum and not none. But if the result is none, the code fails right here. And also we are destructuring the datum from here. We are putting the value, this value datum, whatever this is, we are putting it in a variable called datum. Okay, clear?
Yeah, thanks. It's clear.
Okay,
it's clear.
Okay, perfect. Similarly, here you are saying expect some own input is equal to find input, inputs dot input. So here they are using a function called find input. And here also you are using the same design pattern. Okay, expect sum. But why are you using expect sum here? To understand that, let's look at the find input function. We can go here and we can just type in find underscore input. So any guesses on what this function does? Any guesses before we jump in?
Okay, I'm going to say that it searches out the exact input that was given earlier in your lines of code. Yeah.
Exactly, that's perfect. So it just takes in a list of all inputs and it takes in the output reference, which is one input, and it gives you the full input, optional full input, that if this exists in this list. And so why is it wrapped in option? Can anyone guess why this is wrapped in option?
Because the datum can either exist or may not
This has nothing to
exist.
do
Yeah.
with datum, by the way. This has nothing to do with datum. Did you say data or datum?
I said datum. Datum.
Okay. This has nothing to do with datum. The option has nothing to do with datum. Option just means it either exists or it doesn't exist. So whenever something doesn't exist, so we put option. So for example, what are we looking? We are looking for this specific input from this list of inputs. So there's no guarantee that this input exists in this list of inputs. That is why we put option. Is that making sense?
Yeah, it is. It's making sense.
Okay, perfect. And can anyone tell me what an output reference is? And why am I calling this an input? Because it doesn't say input anywhere. So why am I calling this an input? Does anyone know what an output reference is? And I think someone mentioned that like Emmanuel taught you guys about this. So just from your memory, can anyone tell me what an output reference is? Any guesses? I'll give 5 seconds for this. Okay.
Well, out. Okay, I'm just trying to do. Yeah. So output reference is like it gives you like a glimpse, or should I say, a rough idea of what the output of the like the result of the inputs might be. Yeah. So I don't know.
So think of it like this. Input is a big object, okay? And if you want the name of each input, you use the output reference, okay? That is a specific identifier for each input. So let's see what an input object is made of. So if you go to input, an input is made up of output reference and the output, okay? So each UTXO has both of these. Any UTXO, unspent transaction output, any UTXO can be recognized by the output reference. So this is the name of the UTXO. Think of it like that. And the rest of the information exists in output, okay? Think of UTXO as a simple input. Any input, every input is a UTXO. Remember, inputs can only be UTXOs, right? You can only spend UTXOs to create new UTXOs. So the name of the UTXO is the output reference, and the rest of the information is the output. Let's quickly see what an output contains. An output contains simple information. So there is this address right here. What is this address? So every UTXO, like I said, exists inside of an address. Remember? Every UTXO exists inside of an address, right? So the address that we are looking at is this address, okay? And what else did we say it contains? A UTXO has to contain value. Whatever is the value, it has to contain value, and it can optionally contain datum, which is information. And on top of that, there is one more thing it can optionally contain, which is reference script. So think of reference script as a specific kind of information as well for now. Okay, we'll talk about reference scripts later, but think of it as a specific type of information that it can hold. Okay, this is all the information about one UTXO. Now, let's look at what the name output reference means. How is a UTXO defined? Oh, Emmanuel, go ahead.
Yeah, the on the reference scripts, like I would like anyone to talk about the reference script, because I think we've also discussed about reference scripts in the past.
Oh, you want to take a look at the reference scripts?
So like anyone anyone should talk about the reference scripts.
Yeah, so
like I just want to hear the idea on what they think about reference scripts.
So for me, a reference script is
Actually, Actually, I mean the students,
Oh,
like,
for the students. Okay, yeah, go ahead.
like I just want to hear the idea.
Yeah.
Anyone?
Okay, 5 more seconds, and then Emmanuel can answer that question. Okay, Emmanuel, down to you. What do you think a reference script is?
Yeah, a reference script. I've actually discussed this, multiple times. Just yeah, a reference script is just like you are specifying a script to a UTXO. Like that's a validator. You see that is a script hash. That's saying this UTXO this output, this UTX, so we are just specifying it to reference a O validator body, just like that code right now.
Yeah,
Just like
yeah,
that code, compiled code, the O compiled code, you can, give another person the UTXO that just try to reference the script in this UTXO, and yeah.
yeah. So, for example, we were looking at different validators, right? What I can do is I can hash this validator. I can hash this validator, and I can put it in a UTXO, and it'll go here. Okay, I can just hash that whole validator and put it here, and it'll just go here.
And
That is,
yeah,
yeah.
and Asha, can you go to the Plutus.json and show them the validator hash?
1 second. Plutus.json. So I didn't like do the Aiken build for this, but in general, this is how it looks.
Yeah.
In general, this is how it looks. So for example, you see week 0 marketplace.spend. So in week 0, there should be a marketplace validator. I right now I have kind of like commented it out, but it will have a spend endpoint somewhere. Let's look at that quickly. Where is this? Oh, this is a big validator. 1 second. Yeah, see, look at here. So there is a validator called marketplace, and there is a spend endpoint in that validator. That's exactly what this Plutus is saying. So this Plutus basically gives us information, consolidated information about all the validators that we are trying to use. It gives consolidated information, and it compiles the code. It compiles the code. So this is the code that it has compiled to, and this is the hash of that code. Is that making sense?
And that's basically the script hash.
Yes, this is the script hash. Yeah. Um, let's go back. I think I've confused you guys enough in the middle. But let's go back to where we were. So we were just reading these lines, right? So find input. So we just wanted to find this input from this list of inputs. And instead of sending an input, we just gave it an output reference. Output reference, remember, output reference is just the name of a UTXO. So if you want to take a look, if you just go to a list of UTXOs, what do you see? All you see is output references. There's a transaction hash and a transaction ID, which is the number after the hash mark. There's a transaction hash and an ID. So what does this even mean? What is this transaction hash and this transaction ID? So let's look at this, for example. Okay. A transaction hash, which is this, basically references a specific transaction. Okay. And that transaction will have multiple inputs and multiple outputs, correct? So in this one, there is only one input and one output. Okay. So the transaction the transaction, what's that called? Transaction index. So this 0 is just the where the output is in the list of outputs. Say, for example, there are 5 outputs and you see the 0 here. That means in this transaction, which is 165 dash dash 436, this was the first output. Okay. And if you see 1, it is the second output. If you see 2, it is the third output. So it's just the list of output in this specific transaction. Is that clear? Because I feel like it can be a little bit confusing. Now is a good time to ask questions if it is making sense and why I am saying this output reference is the name of a UTXO specifically. Is it making sense? Or are you guys already like confused and you're like, what is going on? Okay, how about this? Are you clear about what an output reference is? Does this part make sense?
Yes.
Okay.
Yeah.
Yes, it does.
It does. Okay, perfect. Okay, as long as that, so, okay. So now that you know what an output reference is, so in this find input, all we are saying is, you see the output reference here? Instead of giving the whole input or the UTXO that we want to spend, we can just give it the output reference because every UTXO will have a unique name, which is the output reference. So just by giving it the name, you know that, hey, this is the UTXO I want to spend. So for example, I can give my first name and last name and you'll be able to recognize me. I don't have to give my address and my street number and all of that, right? I can just give my name, and that is exactly what this output reference is. And in this input, we are just giving the output reference to find this specific input from this list of inputs. Emmanuel, go ahead.
Yeah, just wanted to add, you can just imagine the output reference itself as an identifier to the UTXO, and the main identifier is the hash and the index. So that's the output reference. But the input itself is the whole UTXO body, and it will have an identifier on top of it, and that's the output reference. And the output is the remaining body. I don't know if that makes sense.
Yes, yeah, exactly. So it is identifier. That's why I'm just calling it a name. It's the identifier, and the rest of it is like the rest of the details about the UTXO. Yeah. So anyway, so here in this line, we are using expect sum again because this specific input might exist in this list of inputs or it might not exist. That's why we are saying this input has to exist, otherwise fail in this step. That is what it is saying. But if this input exists in this list of inputs, please call that input own input. That is how you read this sentence. I'm guessing you all understand this, but if you don't, like, please feel free to unmute and ask questions at any point in time. Okay, so now we are done with this line. Let's do this. Let own address value is equal to get all value from. Can anyone guess what this means? What this function does? Get all value from. It is taking inputs, a list of inputs, and own input output address. What is this doing? Any guesses? We'll actually look into this function. Yeah.
Okay, yeah. I think it's trying to tell you, it's trying to like indicate that whatever value you want to get, like it's trying to like give a reference point to whatever values you want to get. Like the source is telling you that this is where you get your values from. Yeah. So that's what I'm saying.
Yes. It is not just giving a reference, it's actually giving out the value. It is giving out the value object. It is saying from the inputs, find all the value that is coming from this address and add it together and give me this full value object. So it will give you the whole value object. That means it will give all the Lovelace coming from this address. If there are any other tokens, it will give all the other tokens coming from this address. Okay, that is what this will do. If you want to see how this function works, they have defined it right here. This is the same thing, input value from address. It takes a list of inputs It takes an address and it gives out value. And how is this working? First list dot folder. Fold is like a very fun, it's a super fun function. Okay. So this is fold right. This is how it is read. Fold from right or fold from left. Why do we care whether we are folding from right or left? It depends on the specific function. For example, I say 1 plus 2. It doesn't matter whether you fold from right or left. 1 plus 2 is the same as 2 plus 1. But if I say 1 minus 2, then it makes a difference whether you're folding from right or left. Because 1 minus 2 is not the same as 2 minus 1. So that is when left or right comes into play. But here, fold right or fold left, it's the same thing, to be fair. Yeah. So what is happening is this function is folding a list of inputs and giving out an accumulated value, whatever that is. And the initial value for the accumulated value is 0. Okay. And this function is taking one input. So from the list of inputs, it's taking the first input, it is putting it here. And what is it doing? It is checking if this input output dot address is equal to the address that is given here. If it is equal to the address, merge in the accumulated value. If it is not, keep the accumulated value as is and give the final value. Does it make sense? Does this function make sense?
Yes, it does.
Okay,
Yeah,
perfect.
please just come again. Yes. Yeah.
So is there a specific part that you would prefer me to explain more?
Yeah,
Or just
the
Uh-huh.
yeah, the part you just explained just now, like, do you mind just coming again?
Yeah, so I'll just
again.
explain it really quickly. So this is a function called input value from address. It takes the input parameters as the list of all inputs and a specific given address, and it gives out a value. This is called a signature of a function. So that means it basically shows you what inputs it takes and what output it gives. So this is the signature. And let's see how this function actually works. So this function takes the list dot folder. That means you are taking a list and folding it into an individual value. That is what fold means. Fold R is folding from the right side. You can either fold from the right side or you can fold from the left side. This is a list, right? It can either go this way or that way. And how does this folder work? You give the list of inputs and then you give an initial value of 0, which is the accumulated value. So because we are creating a value, right? What is the initial value of this? It is 0. Or we can start with any value, but in our case, we're starting with 0. Okay. And then there is this function that takes the input and the accumulated value, which we defined as 0, and it starts checking if the address inside of this input is equal to the address we gave here. If this address and the address inside of that input match, then we are adding that value inside of this input. This is each one input inside of the list of inputs. We are adding that value to the 0, which is our initial 0. Okay. Otherwise, we are just keeping the accumulated value as 0. That is for the first input. And then we go to the second input and do the same thing. We do the same thing with this function. So this function will keep processing until we go through each input in the list of inputs. And then we finally get the accumulated value, which is of the type value. Make sense?
Yeah, I'm good.
Okay, perfect. So now you know what that function does. This is slightly different, but it is kind of defined similarly. If you want to see how exactly this function is defined, it's also the same thing. You are giving inputs and you are giving an address, and it basically accumulates all the value that is going to the own address, that is coming from our own address. Okay. So now we have all the value coming from our own address. In this case, can you guys tell me what our own address is? What is our own address? Whose address is this own address? Any guesses? Any guesses? 5 seconds. Any guesses? What address is this own address? Where did we even get this own address from? What is this own address? So even before that, can you remember what this own input is? Where did we get this input from? Input is just a UTXO, by the way. Where did we get this UTXO from? Okay, I will explain. This own input is derived. So this own input is a UTXO that exists in the address, in this validator address itself. Like we discussed, there are two types of addresses. One is our own addresses that we control, and validator addresses where the validator defines what conditions need to be met to spend that specific UTXO. So this own input is a UTXO that exists inside of this validator address. Make sense? And that is why we are calling it own input. And what is the validator address? It is the own validator address. Own validator address is the address of this specific validator. Is that making sense?
Yeah, it's making sense.
Yeah. So this specific line is saying, hey, I want to know all the value that is being spent from this validator address. That is why it is own address value. Okay. So let's go to the next line. Let is Lovelace value enough. Okay. So it says value GEQ means greater than or equal to. Value greater than or equal to own address value, which is the total value from this validator address. And it is being compared to from Lovelace. From Lovelace is, it's basically a function that converts integers to Lovelace. Okay. So can anyone explain this line to me? And by that, I mean, what exactly is happening in this line? Can anyone explain? So take 2 minutes. Wherever you have questions about this line, for example, I don't know what value GEQ means. You can always go to your, where is that? You can always go to Vodka, and this is where you'll find value GEQ. How do I know it is from Vodka? Just go to the inputs, sorry, just go to the import statements, value GEQ. So this is in Cocktail. Cocktail library and Mocktail library are in the Vodka, are in the whole Vodka library contains both Cocktail and Mocktail. So go check out what value GEQ does. Go check out, where is this? So this line, go check out what from Lovelace does and take 2 minutes to explain this line to me. And I'm going to wait 2 minutes. Anyone?
Yeah, according to what you said, you were like that's the value is GQ means like greater than or equals to that in the own address, like the value is greater than or equals, check if the value is greater than or equals to that in the own address. And that from Lovelace aspect, I'm kind of lost in that aspect, but so that's that.
Yeah, no, I think you're absolutely right. So datum, you remember what is defined in the datum? We defined an integer in the datum right here. It says minimum script Lovelace. That is basically saying you have to spend, so this specific, should where's this slide? I missed it. Okay, so this is saying make sure the value that is being spent from my own address, the ADA value that is being spent from my own address is at least equal to this value that I specified in the datum. Okay. Make sure it is at least equal to the integer that I specified in the datum. And the reason for converting that integer into Lovelace is because in the value object, it only recognizes Lovelace, policy ID, and asset name. It does not recognize integers, okay, because it only recognizes integers as quantity. Okay, does that make sense? So you're basically converting this to value, and then you're comparing two value objects. Cool? This line makes sense. So similarly, can you explain the next line to me, which is also very, very similar? This one is comparing ADA value. What is this next line comparing? Any guesses?
Can you, okay. I
Go
think
ahead.
what's being compared here is the policy ID. If it is equal to what we have in our own, you know, in our own validator.
Correct. So it is not just comparing policy ID, but it is comparing this one, data minimum script token. So it is saying, so what is data minimum script token? Minimum script token, it is an integer. They are saying, oh, where is this? Where's this line? They are saying it doesn't matter what policy ID is. Whatever policy ID is, it has to spend these many script tokens. It has to spend these many, because we are only defining the number in the datum, and the policy ID is this policy ID. Token policy ID. I think that is the same token policy ID, right? Token policy ID. Yeah. So we have given these parameters. So this token, a minimum number of this has to be spent when you are unlocking this UTXO. That's what it is saying. Does that make sense? I think you got it right. It was policy ID and it was token name. And from the datum, you're checking the minimum number of tokens that you have to spend. So putting all of these together, what is it saying? So the final, can you guys tell me what the final line of a validator always is?
It either returns true or false based on the logic that we have passed to it. So here, I think we are trying to say, yeah, it's
Yes.
lovely
No, that's
enough,
exactly it.
and yeah.
That's exactly it. Yeah, you got it. We are trying to say, did we spend enough Lovelace when you're spending that UTXO? That means, does that UTXO contain at least these many Lovelaces or this much ADA? And does that UTXO contain at least these many tokens with this specific policy ID? If it is, then please spend. This transaction will go through. Which transaction will go through? This transaction will go through. That means you are able to spend this UTXO through this transaction. That is what is happening. So are you guys clear with this validator? Any questions? Now is a good time before we go to some tests. Any questions? If not, we can jump to the tests. Can anyone tell me what exactly are we testing? Oh, go ahead. I can see your hand raised. You can unmute and speak.
Yeah,
Oh,
yeah,
yeah.
yeah. I wanted to clarify my understanding on that last sentence. That last question you asked us, right? So you said you are trying to, like, is a, like, how will I put it? Yeah. So you said that if it's true, like if the transaction passes. Oh, sorry, I don't know how to put it. I just want to like rephrase your statement here for
Yeah.
the last
So
line you chose.
yeah, exactly. So what is this? This is a spending validator. Okay. This is a spending validator. This validator gives permission to spend this UTXO. Okay. If this validator returns true, that means it is giving this transaction permission to spend this UTXO. Okay. Is that clear? And remember, I'm saying this transaction, you're giving it permission to spend this UTXO because the transaction can have a lot of other inputs and outputs. It can be minting something, it can be spending something from somewhere else. But in this specific case, this validator is giving this transaction permission to spend this specific UTXO. Make sense?
Yeah, those make sense now.
Yeah. That's what it is. And now let's jump to some tests. Testing is like one other big pain in the ass when it comes to blockchain development, by the way. So when we test this, what even are we testing? Like, how do you test? Like, what are we giving it? How are we testing? Does anyone know? Does anyone have an idea? So what exactly is happening when we are trying to test a validator? Any just opinions, like feelings, anything? What is testing when it comes to the blockchain? Okay, let me try to give you like a high level understanding of what a test is when it comes to writing validators. So what you are creating is all the parameters that go here inside the validator. So if you want to test if this validator will give true or false, you have to give it all these parameters, these two parameters plus these four parameters. Okay. And the main thing in all of these, because the datum optional, the redeemer, the input, all of these will just be a part of the transaction. The transaction is the big object that we'll be creating and testing. Okay. So by the end of the day, most of our testing has to do with recreating the transaction object and manipulating the transaction object. Let's see this. So this is the defining the test case. This is a specific style that Hinson writes in. Hinson is the guy who actually, Hinson and the Sedan Labs people, they are the ones who created this Vodka library, by the way. So they have a very specific style of writing the tests, and this is their style. So they first of all, they define a test case. What are they saying? Is minimum script loveless provided? If yes, that means this is a passing test. If no, this is a failing test. Similarly, is minimum script token provided? If yes, passing test, otherwise failing test. So when does this test pass? When both of them are true, that is when the test passes. Okay. So they just defined the test case initially. Now you can put this aside. Now they defined a base transaction. So look at this function. They have defined a function called mock transaction that takes the test case that we defined right here and gives out the transaction. That is what this function does. Okay. Mock transaction. So I think if you go here, if you go to the mocktail library, you'll see mock transaction somewhere here. Functions, mocktail transaction. Okay. It is a function that just creates a transaction object. That is what the mocktail transaction does. Okay. And then you can inject like little things. First of all, it creates this transaction object, and then you can manipulate the transaction in, and then you can manipulate the inline datum and the transaction out. So all the things in the transaction object you can manipulate. So you have this transaction, big transaction, and you can manipulate all of these fields depending on what you want to put in your transaction so that it can either pass or fail a specific validator. Okay. So in this case, let's see what they did. So they have created a function called mock transaction that takes the test case and gives out the transaction. and they created a variable called test case. Sorry, an instance of this type called test case, because they used the constructor test case, and they gave these two values. So this is a destructuring statement. This is very, very similar to what we did right here. This is very similar. They have destructured the fields from the transaction object. Similarly, here also, they have destructured the fields from the test case object. Make sense? And after that, after they destructured it, they called the mocktail transaction function, and they inputted. So are you guys familiar with the pipe operator? Does anyone know what a pipe operator is? 5 seconds. Can anyone tell me what a pipe operator is? That is this operator. Anyone know what this operator does?
It has been quite confusing. I think it will be better if you explain.
Yeah. So a pipe operator is a very simple operator. What it does is it pipes in a specific value into a function. That's all it does. Okay. It pipes a specific value into a function. So for example, say a function, this transaction. Oh, Emmanuel, go ahead.
Yeah, or you can just say maybe it adds or it joins to it joins a specific value to a function.
So it adds the first parameter to that function. Say, for example, a function takes a bunch of parameters, right? So this mocktail transaction creates a parameter, right? It creates an empty transaction object or whatever it creates. That transaction object is piped into the transaction in function as the first parameter. And then this true mock transaction hash 0, all of these are the second, third, fourth, and fifth and sixth parameters in it. How do I know? Let's take a look at transaction in. TX underscore in. So what is the first parameter? Mocktail transaction. And then the second parameter is bool, third is transaction hash, transaction index, all of this. So in this case, we created the mocktail transaction here and piped it in. That's why we didn't start with the first parameter. We started with the second parameter, if you notice, because the first parameter is mocktail transaction. So we just piped in this value using the pipe operator. Does that make sense? Is that making sense? So you get a value from running this function mocktail transaction. Whatever that value is, you are pushing that value into the transaction in function. And whatever value we get from both of these, we are pushing it into the next transaction in. And whatever value we get from all of this, sorry, what is this? Whatever value we get from all of this, we are pushing it into the next one. So the sum of all of these values will be pushed into the next one. So it's basically like a chain. The first value goes into the next value, the next value goes into the next value, like that. And that is how we are using the pipe operator. Is it clear now? Is the pipe operator clear? If you have any questions, now is a good time to ask, and then we'll move on to the next situation. All clear?
It's clear. It's clear.
Okay, cool. So now in this, all we are doing is we are designing, or we are building the transaction object. So we have one input here. We put in one input into the transaction object. We put in a second input into the transaction object, and a third input and a fourth input. And then whenever you call the complete, that means it is saying, hey, complete, this transaction object is built. That's all is happening. And how are we building the inputs? So this true here, it's a Boolean, right? What's the point of this random Boolean here? Because this Boolean takes in your test case. That is the point of this Boolean. If this Boolean is false, this function doesn't run, by the way. This function does nothing. This function only runs when this Boolean is true. Okay. And then you are piping in a mock transaction hash. Mock transaction hash is any transaction hash. So you'll have to build each field inside the transaction, by the way. Inside, yeah, you'll basically have to build each field. Mock transaction is you're building a mock transaction by giving a random number 0. Okay. And then what is this 0? I think it's the transaction index. You got have the transaction hash and you have the transaction index. This is the UTXO we are spending, by the way. This is the UTXO we are spending because it has a transaction hash and it has a transaction index. And then you are basically putting the amount of Lovelace that this specific UTXO has. And also you are providing the script address. You are creating a mock script address and providing a script address. Yeah, go ahead.
Yeah, okay, yeah. I remember that Lovelaces represent either like 1 million Lovelaces is equals to 1 either. So right, those amount of Lovelace, that's 10 million, right?
That is
They
10 ADA.
represent
Uh-huh.
yeah, 10 either. Okay. Oh yeah, yeah, yeah.
Yeah,
Yeah, I'm
always
good.
remember 6 zeros. That's it. 6 zeros is 1 ADA. And after that, this is the first two numbers are or whatever this number is the number of ADA. And then make sure there are 6 zeros. Then it represents Loveless. Yeah. Yeah, so basically we are piping in all the transaction inputs and we are completing this function. So this function basically destructures the test case, and depending on like these values, like it'll pipe in like the different transaction inputs. See, for example, this is always true, but this one is either true or false depending on our test case here. Again, this is always true, but this will either run or not depending on our test case. That is how test cases are used. And then they'll be running some tests. To run the test, they have defined some datum. Okay. And how did they define datum? It is wrapped in sum of the type datum, and they have filled in each field of that. Okay, so why did they wrap it in sum? Because datum is optional. Remember, when you are putting the input here, data optional, it is wrapped in option and then it is defined of the type datum. So that is why sum, it's of the type datum, and inside of that you're giving each of the fields. Hey, did you still have like a question? Or okay, that's by mistake. Okay, cool.
Oh, sorry, I forgot my answer.
It's all good. It's all good. I was just curious. Yeah. So you define the datum here, and here you are calling the transaction. The transaction is equal to mock transaction, and then you give it the test case. And then the transaction is built. The datum is built, the transaction is built, and then you directly call your validator. This is how you call your validator. So by calling the validator check script input value dot spend, that is how you call your validator. What is our name of our validator? Check script input value. And you're calling the endpoint, which is spend. So dot spend. And to call this endpoint, what all inputs do you need? Let's take a look here. What all inputs do you need? You need a mock policy ID. You need a asset name. You need the datum. You need what else is here? You need the datum. You need the redeemer. You need the output reference, and then you need the whole transaction. So those are. And by the way, when you are calling the endpoint, you need to make sure all of these parameters are exactly in this order. If you change the order, it'll get screwed over. So first one has to be policy ID. Second one has to be asset name. Third one has to be datum, and it has to be of the type optional. The fourth one has to be a redeemer, which is of the type data, this is any general data. Output reference, and then transaction. If you look at this, when they call it, these will be in the exact same order: policy ID, asset name, datum, redeemer, output reference, and then transaction. Okay, so now just let's test this test this test case. Let's clear this. And does anyone remember how to test? What is the command for testing in Icon?
Icon check. Icon check. Then
Exactly.
you use the validator. Yeah.
Icon check, and then what
The
do I do next?
validator name.
So if I want to test this, say for example, this, do I have to use the validator name?
Yeah. Use the validator name.
So we don't have to
no,
use the validator
no.
name. You just use -m. -m basically looks for the exact name. Say for example, I want this name, right? So I will copy this. I will copy this. I'll give it a space and do this. So this M is looking for this exact name of this test. Okay. And then if you do this, let's see what will happen. One test passed. And which test is this? MD202L22 test success. So this is the test. Okay. So you don't have to use the validator's name, but you have to use the test's name. Okay. Make sense? And M is basically pattern matching. It looks for that specific name. Okay, now I'm going to give you a little test. If I want you to make this test fail, don't have to go to the next one, just this test. What would you change here to make this test fail? Any ideas?
Yeah, okay. I don't okay. If we had none to it, it will fail, right?
If we had what?
None.
None. So you're talking about datum, right?
Yeah.
Let's do that. Yes, what I'll do is I will comment this out and I'll say none. Let's see if it fails or not. And it has failed. You're right. So now you know that is one way of making the test fail. Okay. So can you think of any other way of making the test fail? So I'm going to, so now you don't, so
Can you hear me?
yeah, go ahead.
One other way we can make the test fail is if we alter any of the test cases. For example, is minimum script Lovelace provided? If we say
Very
false,
nice. Yes,
the
let's
test
try that
fail
then.
actually.
Let's try that. So what do you think? Do we have to change both for it to fail, or if we just change one, it would fail?
We are comparing the boats. We are returning. If you change one, it will fail.
It should fail, right? Like, let's see.
Yeah. 1 and 0.
Let's see. And you're right. If we change one, it fails. Let me change the other one and test. Let me see if it fails if we change this. And it failed again, I think. Yep, it failed again. So any one of these, if you change, it fails. So let's change these back to true. Yes, go ahead.
So okay, what if we change both to false? Will it still fail or will
Yeah,
it pass?
let's try it. I mean,
I think it will fail.
oh shit. All right, we change both of them. Let's see what happens. It fails again. So I'm going to change them back to true. Change this back to true. So now I have another question for you guys. So we have, oh shit, we went past time. Okay, 5 more minutes and then we'll be done. So for example, here in the validator, we are checking to make sure that exactly the same greater than or equal to this value has to be spent, right? So in the mocktail function, in the mock transaction function, what would you change so that the validator fails at either this place or this place? What would you change in this function? So think of this value, so 15 million ADA, sorry, 15 ADA and 2 tokens as the standard datum value. So if our validator has to fail either here or here, what would I change in this function? Any guesses?
Wait, please, do you mind highlighting that specific line of code? Do you mind highlighting it again?
These guys?
No, the other guy down there, down there.
Down here, this one?
Yeah. You were explaining, you were like, what changes do you have to make here? Then you highlighted the particular code here. So is that particular one I want to see?
So what I'm saying is, so when I say datum is set, that means in the UTXO you are spending, it has to have a minimum of 15 ADA and minimum of 2 tokens with the policy ID that is specified with this policy ID. Where's that policy ID? With this policy ID and asset name. Okay. So now what would you change in this function so that that value is not, that specific requirement is not passed? So for one of these two to fail, what would you change in this function? Take 2 minutes and we'll end the session after this.
Hear me?
Yeah.
Can you hear me?
Yes, I can hear you.
Okay, currently I think we're passing about 15 ADA.
Mm-hmm.
The
15
test,
ADA,
so
how come we're passing to 20 ADA, right? 10 plus 10, and this is true here.
okay.
Because both our test cases are true, we are passing
Okay.
20 ADA here.
We are passing 20 ADA, and we are
Mhm.
trying to evaluate if it should be equal to or greater than. I feel if it is less than 20 ADA, it will fail.
No, if it is less than 15 ADA, it will fail.
15 ADA, sorry. Yes,
Yeah.
that's what I'm trying to say.
Yeah. So what would you change in this?
You change the amount of Lovelaces. You reduce the amount of Lovelaces then.
Yeah, to what should I change it to?
You
Anything.
can reduce it like 7 million Lovelaces.
I can reduce it to 7. You're saying 7 like
Yes.
this?
Yeah.
And would it pass or fail now?
Okay, wait. Reduce it to like 4 million.
Yeah, you're right.
Yeah. Then go ahead.
Okay. So
Yeah.
now let's check. Boom, it failed. Because 14 million is less than the required 15 million that they're asking in the datum. Okay. So similarly, can you do it for the same thing if we don't change this and keep this as 10 million? What would you change here for it to fail? Look here. And then look here.
Okay, I think we are passing two tokens.
How did you know we are passing 2 tokens? What line?
You said from asset or something. So
This
we are
one?
passing.
Correct. That's right.
Yes.
We are saying from asset is building just a value object with a policy ID 0 with this policy ID. Oh, shit. With this policy ID no asset name, and quantity of
One
1.
token,
The
and then
same
the
thing is being passed here. So that means we are passing 2 tokens, right?
yeah,
So what
Yeah,
would you
that's
change here for it to fail? What
so
would you
suppose
change?
we do not pass any token on the first input that we are given.
Okay,
will
so
make it
you
0.
just comment this out and then we can check. Did I change it back? Or did I
Yeah.
change the 20 million back? 10, 10. Okay, now let's check.
Mhm. Yeah, it will fail.
It doesn't just fail, it crashes.
Wow.
We just have to not pass that
You just
parameter.
make it 0.
Yes, exactly. Or empty.
Yeah, so can you, 1 second. Okay, let's try it 0, but what is it saying? Why is it crashed? Let me see quickly. Blah, blah, missing fields is what it said.
To
So you have for this function to even go through, this field has to be there. So that is why it crashed. So let's do
yeah,
this and let's just put this as, oh, let's just put, what's happening? Let's
That's
just put
0.
this as 0.
0.
yeah.
And then let's try it.
It will fail.
And there you go, just like you predicted, it failed.
Yes.
Yeah.
Okay. Now, did everything make sense here? How we are testing, how we are writing logic, how we are using this expect keyword, and how we are using sum and option and all of that, and how we are defining types. Has it made a little bit more sense?
Yeah, it has made a lot of sense actually.
Okay,
Yeah,
perfect.
Makes sense. Makes sense.
Okay, okay. So if you want to keep learning and keep doing more, you are always welcome to come to Gimbal Labs sessions and then community code review sessions and all of these things. And keep improving, keep writing more validators, start building apps and stuff like that. It'll be super fun. I think we have like a small group of people here, and more people will be joining, and then we can all build stuff and solve some important problems. All right.
Yeah.
All right.
No problem. No problem.
Thank
All
you
right.
very much.
Awesome. Awesome.
Yeah.
All right. I am going to stop sharing my screen. Emmanuel, do you want to say some closing statements and then I'll run?
Yeah. Oh, thanks so much, Asha, for your time and everything. And yeah, it's actually good for the students to, hear from a different learner. As James as well, maybe James would also be jumping in when once Gimbal Lab session starts, James as well will be taking over, insane yeah. So yeah, it's actually a good exposure to a different learner to take them. Yeah. Thanks so much, Asha.
Absolutely. I completely agree. James is like a much better teacher than I am because I learned from James and my teaching is all secondhand teaching. So yeah,
Yeah.
once James comes back, I think you guys will all like learn so much more. All right, guys, I will run. Have a good time, and I'm very excited to see what all you guys will be building. So see you around.
Yeah.